Hello and welcome. What you're looking at here is a fantastic example of a three-phase AC induction motor, which is truly the workhorse of the modern industrial world. Think of it as a powerful, reliable engine that runs on electricity instead of fuel. These motors are used everywhere, from driving large air compressors and pumps in factories to powering conveyor belts and heavy machinery. Let's break down its anatomy piece by piece. The most prominent feature is its main body, the cast iron casing. This isn't just a simple cover, it's a rugged, heavy-duty shell designed for two main reasons. First, its strength protects the delicate and precise components inside, the copper windings and rotating parts, from the bumps, vibrations, and harsh conditions of a factory floor. Second, and just as important, notice those lines or ridges running along its length? Those are called cooling fins. Like the radiator on a car, they dramatically increase the surface area of the casing, which allows heat generated by the motor to dissipate into the surrounding air much more effectively, preventing it from overheating. At the very bottom, you see what the label calls install a base. These are the motor's feet. A motor of this size generates a significant amount of rotational force, or torque, and vibration. These sturdy feet have bolt holes that allow it to be securely mounted to a solid frame or concrete floor. This is absolutely critical for stability and safety, ensuring the motor doesn't shift or walk during operation. Now, let's look at the business end of the motor. That polished rod sticking out is the motor output shaft. This is the part that does all the work. Inside the motor, electromagnetic forces cause this shaft to spin at a very high and consistent speed. You would then attach a pulley, a gear, or a coupling to the shaft to transfer that rotational power to whatever machine you need to drive. It's made of high-strength steel to handle the immense forces involved. The flat metal plate it passes through is the front-end cover, which does more than just seal the motor. It holds crucial bearings that support the shaft, allowing it to spin smoothly and with minimal friction for thousands of hours. For practical purposes, especially since these motors are quite heavy, there's a strong lifting ring bolted to the top. This is a designated, reinforced point where a crane, hoist, or chain can be attached to safely lift and maneuver the entire motor during installation or maintenance, preventing accidents and making the job much easier. Moving to the side, we find the junction box. This is the motor's electrical nerve center. It's a protective enclosure where the main, high-voltage power cables from the building are connected to the motor's internal wiring. Its purpose is to keep these electrical connections safe from dust, moisture, and, most importantly, from being accidentally touched, preventing electrical shocks. At the opposite end from the shaft, you'll see the fan cover. This is a safety guard, and behind it is a fan blade that is directly attached to the motor's shaft. So, whenever the motor is spinning, this fan is also spinning. It's designed to pull air from the back and blow it forward, directly over those cooling fins on the casing we talked about earlier. This creates a constant, active airflow, a built-in cooling system that is vital for keeping the motor at a safe operating temperature, especially when it's working hard for long periods. Finally, let's look at the information tags. The rectangular metal plate is the nameplate. Think of this as the motor's birth certificate and technical resume all in one. It contains all the critical data, its power rating in horsepower or kilowatts, the required voltage, like 380V, its running speed in RPM, revolutions per minute, and its serial number. This information is essential for engineers and technicians to ensure it's the right motor for the job and for ordering parts. You might also see a separate sticker, often indicating energy consumption or an efficiency rating. This tells you how well the motor converts electrical energy into useful mechanical work. A more efficient motor wastes less energy as heat, which can save a company a significant amount of money on its electricity bill over the motor's lifespan. So, when you see all these parts together, the tough casing, the powerful shaft, the vital cooling system, and the safe electrical connections, you're seeing a beautifully engineered piece of technology designed for power, durability, and reliability.